some of the properties of our odd and even signals. Guys, நம்ம வீட்டுக்கு பக்கத்தில் நிறைய அனிமல்ஸ் இருக்கு. அதை வீட்டில் நம்ம டிஸ்டர்ப் பண்ணிட்டு தான் இருக்கும். Actually all the doors were locked, but I am unable to stop them, right? So நடுவில் ஏதாச்சும் interruption வந்தது அப்படின்னா please adjust for me, right? So let us continue with this. Properties. So in the last lesson we have discussed about even and odd part of the signal, right? I hope you all are getting the very clear idea about the even and the odd part of the signal, right? So let us continue with that. Now we are going to look at the odd and the even signal properties, right? How we are going to see how the properties of the even and the odd signals are going to help us to find out the answers directly in the examination. Let us see now the combinations. Idhukku nam enna pathom appadina I took linear and odd properties, right? Now தனித்தனியா பார்த்தோம். ஒரு ஈவன் சிக்னல் அதை எப்படி அனலைஸ் பண்ணுறது, ஒரு ஆட் சிக்னல் எப்படி அனலைஸ் பண்ணுறது. சப்போஸ் இந்த எக்ஸாமினேஷன் காம்பினேஷன்ஸ் will be given. Combinations in the sense addition of two odd signal will be given, right? So let me take addition of two even signals and then we will take odd signal. Let us take the addition of two even signals. If I add two even signals, then what about the resultant signal? ரெண்டு ஈவன் சிக்னல் ஆட் பண்ணா ரிசல்டன்ட் ஈவனா இருக்குமா இருக்காதா? That is the question. Shall we test? Yes. For that I am taking the example x1 of t given as t square. We all know t square is an even signal, right? So similarly, let me consider one more signal x2 of t. Let us consider cos t. We all know cos t also called even signal. Let us combine them. In result that x of t can be generally written as it is the addition of x1 of t and x2 of t. Now let us see x1 of t can be written as t square plus x2 of t can be written as cos t. Now that is x of t. So the addition of two even signal now add பண்ணியாச்சு. Let us see the resultant signal. For that find out the value of x of minus t. That is x of t. X of minus t equal to minus t whole square plus cos of minus t should be equal to, see there, minus t whole square equal to t square plus cos of minus t equal to what? Cos t only. Cos of minus t equal to cos t. See there, x of t and x of minus t are going to be equal. So the conclusion is addition of two even signal will give you in resultant we are going to get even signal only. Very important property. Please try to register into your mind, right? Similarly, let us take the example, right? Addition of two odd signal, what it will leads, right? Two odd signal. For that, let me take the example. Odd signal in the sense, for example, actually what we are going to consider, we are going to add two signals. ரெண்டு ஆட் சிக்னல் நம்ம அடிஷன் பண்ணோம் அப்படின்னா ரிசல்டன்ட்ல என்ன சிக்னல் வரும்? Please, whichever the things that I am given, you should try to register it in your mind because exam என்ன கேட்பானா theoretically also your questions will be framed. Addition of two even signal in resultant, addition of two odd signal in resultant, addition of even plus odd in resultant. Like that you will be tested, right? So that is what I am telling. Learn the signal system in a beautiful way. Especially you should try to get the overview how to analyze each and every part of the system, each and every part of the signal, right? So you can trust me, you have to follow my guidance. That is what I want from your side, right? So odd plus odd. Shall we test? Yes. Let us take the example x1 of t. For example, x1 of t, let me consider t cube. We all know t cube is an odd signal. Similarly, let me consider x2 of t. x2 of t, let me consider sin t. Now, in resultant, if I group these two signals, then what will happen? T cube plus sin t. That is going to be x of t. Now let us explore the value of x of minus t. X of minus t should be equal to minus t whole cube plus sin of minus t. In resultant, minus t whole cube should be equal to minus t cube plus sin of minus t equal to minus sin t. Now what I have understood here, the thing is, if I take minus outside, it will become minus of t cube plus sin t, right? So that is x of minus t. Now just compare, this is x of t, this is x of minus t. I hope they are not equal, but let us test. Let me calculate the value of minus x of minus t. Further I am multiplying it by minus. This is x of minus t. This ரெண்டு பக்கம் minus ஆல மல்டிப்ளை பண்ணா that is equal to minus x of minus t. Now see there, x of t and minus x of minus t are going to be equal. So what is the conclusion? The thing is addition of two odd signal also in resultant also that will be used to odd signal only. Let us proceed further. Now next what I am going to do, suppose if I take the combination even plus odd எடுத்தோம் அப்படினா அப்ப என்ன வரும்? Just write down the properties, take your notes in a neat way, right? Sketch it, box it, all those things. While revising it, you will get the very clear idea. Trust me guys, definitely you can crack all the questions from signal system because it is very easiest subject, right? And scoring subject also. So let us see. When the moment I am talking about, suppose the combination, I have an odd signal and I have an even signal. Already I only told you ஒரு ஈவன் சிக்னலை இன்னொரு ஆட் சிக்னலோட காமன் that is ரெண்டுத்தையும் கம்பைன் பண்ணோம் அப்படின்னா it resultant what will you get neither even nor odd signal. Yes or no? We know the answer. Let us check, right? So that is the third property. Let us observe it by testing it. For an example, let us consider x1 of t equal to, take one odd signal, let us consider sin t. We know that is odd signal, right? Let me consider one more even signal. Let us consider x2 of t is equal to e power minus mod t. Let me add these two signals. We know this is even signal, this is odd signal. If I already adding I know in resultant x of t will be the combination of odd signal plus e power minus mod t. Even signal. Shall we proceed with this? Yes. So if I proceed with this, next I would like to know the value of x of minus t. Right? I don't know. Now what I have done, odd and even signal has been added together, such that I am testing in resultant whether they are going to get odd signal or even signal or neither even nor odd. We know the result, but we are testing, right? We will prove it. X of minus t equal to sin of minus t plus e power minus mod of minus t. But what we know, sin of minus t can be written as minus sin t only, now. So it is minus sin t e plus e power minus mod of t, that is mod of minus t equal to mod t only, we know, right? So the conclusion is x of minus t is this one. Now I am just comparing x of t and x of minus t. Are they equal? No. So that is not even signal. Let us check whether it is odd or not. Right? To know that, we have to know odd signal in the sense minus x of minus t we have to find. So that is going to be sin t minus e power minus mod t. Again I am checking x of t and minus x of minus t. So this is also not equal and this is also not equal. So the thing is, whenever I am adding an odd function with an even function, in resultant we are always going to get neither odd nor even signals. Clear? I hope now you are getting clear idea, right? Same combinations you will get subtraction also. You subtract now, there is resistance, right? So let us proceed further. Let us next we are going to discuss about multiplication, right? So if I multiply two even signals, then what will happen? If I multiply two odd signals, then what will happen? Then multiplication of odd and even signal. Very important and very beautiful phenomena that we are going to observe now. Let us first, I will take the combination one. Let us consider the product of even with the even signal. When I multiply two even signals, what we are going to get? When even signal multiply, I know what shall we do now? Even signal is example, yes. x1 of t equal to, let me consider cos t. That is even signal, we all know, right? And x2 of t, let me consider some t power 6. That is also even signal, we all know. Now we are going to multiply. When we multiply, resultant enna varum அப்படிங்கறத question, right? So when I multiplying even part 1 with even part 2, ரெண்டு even signal நம்ம multiply பண்றோம், right? If I multiply them, then what will we get? We are going to get t power 6 into cos t, right? Now this is the product of even signal, right? Let me call it as y of t. This group, this resultant value is called as y of t for our understanding. This is the multiplication of two even signal. Shall we check, right? Let us check whether the resultant also even or not, right? For that, this is y of t. Let us find the y of minus t. Up in our room, minus t whole power 6 into cos of minus t. We all know minus t whole power 6 once again will going to be t power 6. Cos of minus t is going to be once again cos t only. See that in resultant also what I am getting, y of t and y of minus t equal now. So the conclusion is multiplication of two even signal also will give you what? Even signal only. So multiplication of two even signal in resultant will be here's to even signal only, right? Let us test whether the same process, that is same result we are getting for odd one also. Odd one in the sense we have to multiply. Multiplication of two odd signal will be resultant, right? What we are going to get. That is what we want to know. Let us proceed. Let us proceed. Let us assume the value of x1 of t is equal to, let me take sin t. Let me take sin t. Similarly, let us take some odd signal x2 of t. For x2 of t, what we can consider? Let us consider e power minus t. Just let me consider e power minus t, right? First we have to check e power minus t odd signal தானா அப்படிங்கறத செக் பண்ணி பார்க்கலாமா? For an example, இது மட்டும் தனியா நீங்க செக் பண்ணுங்க. I don't know for that because e power minus t நம்ம இதுவரைக்கும் பார்க்கல இல்லையா? You might be having doubt. Let us check. This is x2 of t. For that what I am going to do, x2 of minus t should be equal to e power minus of minus t. Here I am going to get e power t only, right? So the thing is what I am getting now. So see there, here I am not getting even signal, so I made mistake. I have to correct it because see there, x of t and x2 of t and x2 of minus t are not equal, right? So let me check. At least minus, because all the odd signal இருக்கணும் என்ன வரணும், இது நீங்க minus ஆல மல்டிப்ளை பண்ணா we are going to get minus e power t only. So the conclusion is this signal is what? This is not the odd signal. So we have to correct it. Take some other example, right? Okay, let me take some other example, right? because we are testing even odd and odd part, na? So for x2 of t, let me consider what I can suggest, t power 7. That is the best example, right? So let us go ahead with this. What I am going to do, x1 of t, we have to multiply them, right? In resultant, let me write y of t. Y of t will going to be the product of the first two signals, right? Product in the sense, just to take x1 of t will going to be multiplied with the x2 of t in order to obtain the resultant, right? Just to we have to take to odd signal, that's all, right? So if I multiply these two, what I am going to get? We are going to get sin t with t power 7. Shall we check now? This is resultant, multiplication of two odd signal. In resultant, what will happen? When the odd signal multiplied now, then paklama y of minus t. First, y of t is known. Find the value of y of minus t. That is going to be sin of minus t into minus t whole power 7. Now, what will you get? Sin of minus t will give you minus sin theta into minus t whole power 7 will give you minus t power 7. See there, it will give you minus sin theta dot, it will give you minus of t power 7. So minus into minus will become plus. So finally we are going to get sin t into t power 7. So what we have understood here, if I multiply two odd signals, see there guys, this is y of t, this is y of t equal to sin t into t power 7. Y of minus t equal to sin t into t power 7. See there, y of t and y of t are going, y of t and y of minus t are going to be what I can say, are they going to be equal? Yes. Sin t equal to sin of minus theta, that is odd function, right? So what I am getting here, sin of minus theta, I am getting minus sin theta. Minus t whole power 7 also I am getting minus t power 7. That is minus into minus will become c plus. So what is the conclusion here? If I multiply two odd functions, in resultant it will be yields to even function. In resultant it will be yields to even function. We can also take some other example to test it, right? So for an example, if I consider x1 of t is equal to, let me consider t power 3, right? And let me consider one more example with this. Let me consider x2 of t should be equal to t power 5, right? See there, both are odd signal only. If I let it multiply, right? For your understanding, x1 of t into x2 of t will be equals to what? T power 3 into t power 5 will be equal to t power 8. T power 8 is an even signal. So the conclusion is multiplication of two odd signal will always be equals to even signal. Clear? Yes. So let us proceed further. Let us see the next model. Suppose if I have the combination odd into even, let us see. Guys, don't forget the relations that I am giving here, right? Because even I don't like to memorize anything here. I'm not memorizing anything. The thing is, we have to understand the process. Once you will understand, even in examination, if I forget anything, definitely I will start deriving all these things within fraction of a second. Because we know the procedure, we know how to bring the answer. That is the way how we are analyzing the subjects. Clear? That is very important, right? So let us check. Next combination. Suppose if I consider odd into even function. Odd into even, right? Let us see in resultant what we are going to get. Now you can take example, you can do it by yourself. Anyway, let us proceed by ourselves. So I am doing here x of t. First we have to consider some odd function. Further I am taking sin t. That is our famous example, right? So let me consider even function. For even function, let me consider some t power 4. Let me multiply them in resultant. So y of t, I am going to multiply them even and odd such that we are going to get t power 4 into sin t. Now let us see, find out the value of y of minus t. Y of minus t is going to be minus t whole power 4 into sin of minus t. So what is the conclusion here? Which should be equal to minus t whole power 4 equal to t power 4 only. But sin of minus t will give you minus sin t now, so that will be minus of sin t. So what is the conclusion here? Y of t and y of minus t are going to be, they are not equal, right? So what I am going to do? Multiply by minus. If I multiply by minus, so it will become plus. So that is minus y of minus t should be equal to plus t power 4 into sin t. So conclusion is y of t should be equal to minus y of minus t. What is this? If I multiply an odd function with an even function, in resultant we are getting odd function only. Don't forget, very important relation. Actually, at this point, many people are making mistakes. The mistake is, we are thinking logically, normal products only compare பண்ணிக்கிறீங்க. Normal products na 2 அப்படிங்கிறது even number, 3 அப்படிங்கிறது odd number. ரெண்டுத்தையும் மல்டிபிள் பண்ணா even number தான் சார் வருது. So in that logic you people are making, here people are putting even, but that is wrong. In sequential system, when I am multiplying an odd signal with the even signal, I am getting odd signal. We are not getting even signal here. So this kind of misunderstanding is wrong here. Don't go with the blind logics here. That is wrong. Okay. So this is the basic fundamental properties of odd and even signal, right? Now with this, if I will give, that is if we are given இப்போ ஏதாச்சும் ஒரு big example கொடுக்குறாங்கன்னு வச்சுக்கோங்களேன். Now you can easily find out the odd and even part. Let us say we know the properties now. We know all the properties of the even and odd part of the signal, right? So with this, let us proceed. For an example, if one function is given like this, y of t is equal to t square into sin t, right? Let me consider t cube into cos t. Let me consider t square into cos t, right? Or cos of mod t, right? So let me consider e power minus mod t into sin t, right? Something it is given like this. If in the way you are requested to find out the odd and even part of the signal. Odd and even part of the signal. How will you do it? If in the question even and odd part, very simply you can do it. See there, first you consider t square அப்படிங்கிறது even function. We all know. Sin t அப்படிங்கிறது odd function. Now product of even and odd என்ன கொடுக்கும் நமக்கு? Product of even and odd will be result an odd function. Yes or no? Yes. So the conclusion is this function is an odd function. Similarly, t cube odd function, cos t even function, product of odd and even. Just now we saw product of even and odd will give you odd function. Just now we saw. Similarly, t square even function, cos of mod t that is also even function. Even and even in resultant it will be used to even function. E power minus mod t even function, sin t odd function, product of even and odd will give you odd function. Now the question is what? Break. Even part of the signal மட்டும் கேக்குறாங்க அப்படினா this is the even part of the signal. So the answer is t square into cos of mod t, that is the even part of the signal. Whereas odd part of the signal கேட்டாங்க அப்படினா you have to write t square into sin t plus t cube into cos t plus e power minus mod t into sin t. Clear? So that is how easily we are finding the even and odd part of the signal. Clear? So let us moving on to the next type of signal. So this is all about the basic fundamental properties of even and odd part of the signal. Let us proceed with this. Now we are going to discuss about a next beautiful question that is called. It is same as our even and odd part, but slightly different. We are going to do the same thing in our complex signals. That is called. We are going to look at the properties of conjugate symmetric and conjugate antisymmetric. So keep that in. Next we are going to discuss about conjugate symmetric and conjugate antisymmetric. So let us say conjugate symmetric. Conjugate symmetric. So we are going to discuss. That is, we are going to find out the properties of conjugate symmetric and conjugate antisymmetric. Conjugate antisymmetric. So we are going to discuss about two people, conjugate symmetric and conjugate antisymmetric, right? Okay, now there is no big difference. It is same as our even and odd parts, right? Let us see, understand these things in the engineering mathematics point of view. Again and again I am repeating how to solve these questions numerically. That is the basic overview that you have to learn as up to now, right? After joining in some PSUs you can get the overview if you are working for some signal processing, right? And the mari unit la neenga work பண்ணும்போது you will come to know how நீங்க learn பண்றது நீங்க application apply பண்ணுவீங்க, right? We are in basics of the engineering mathematics, that is signals and system. So learn all those things in the mathematics point of view. Again and again I am repeating, right? Then only you will be able to crack all the questions. Okay, let us proceed with this. Now conjugate symmetric. What I am going to do, a signal is said to be an conjugate symmetric, right, when the value of x of t will become equal to the value of x conjugate of minus t. That's all. Adai nam enna pathom, symmetric signal அப்படினா meaning என்ன? Symmetric signal அப்படிங்கிறது even signal, right? Guys listen, what is the difference between even and odd signal? Even signal in the sense it is symmetric about the vertical axis. Odd signal will be symmetric about the vertical axis, antisymmetric about the vertical axis. Antisymmetric, you can see there, first and the second quadrants are symmetric to each other. That is called symmetrical. இதே vertical axis ல first axis இங்க நம்ம மேல வச்சோம் அப்படினா இதுல symmetric இங்க வரும், அதுக்கு அப்புறம் அதுக்கு antisymmetric, அதுக்கு reciprocal எடுத்தீங்கன்னா first quadrant and third quadrant are going to be equal. See there, first signal, that is first half, இதுக்கு வந்து நீங்க mirror வைக்கிறீங்க about the vertical axis. If I keep a mirror, this half will be reflected here and then I have to take anti-symmetric. The reciprocal எடுத்தீங்க அப்படினா we are getting antisymmetric, right? So antisymmetric in the sense we are talking about odd signal, symmetric in the sense we are talking about even signal. So even signals are called symmetric signal, odd signals are called antisymmetric signal. Now what is the difference here? அப்ப இங்க நான் என்ன பண்றேன், conjugate symmetric. Symmetric means even signal. Conjugate of symmetric signal is called conjugate symmetric signal. Similarly, conjugate anti-symmetric. Anti-symmetric means odd signal. Conjugate of anti-signal. Just we are going to take conjugate for our anti-symmetric signal. That is odd signal we are going to take conjugate. For even signal I am going to take conjugate. That is the one of the new thing that we are getting from that. There is no point of memorizing the things. அப்படியே நீங்க ப்ராப்ளம்ஸ் பிராக்டீஸ் பண்ணா இது மைண்ட்ல அப்படியே ஸ்டோர் ஆயிடும், ரைட்? சோ யூ டோன்ட் நீட் டிஃபரன்ஷியேட். இது தனியா அது தனியா நீங்க பார்க்க வேண்டியது இல்லை. ஈவன் ஆட் தெரியாத இருந்தது அப்படினா கான்ஜுகேட் ஆல்சோ வில் கெட் தி ஐடியா. In clearest way you will get the clear idea. Let us proceed further. What is the conclusion here? So x of t equal to x conjugate of minus t, right? So இந்த மாதிரி ஒரு கண்டிஷனை satisfy பண்ணுது அப்படினா that signal is called conjugate symmetric signal. Similarly, conjugate anti-symmetric signal in the sense if a signal is satisfies the properties, if x of t is equal to x conjugate of minus t into minus. We know for an anti-symmetric the property is x of t is equal to minus x of minus t. Conjugate of anti-symmetric in the sense we have to take conjugate for the given signal. Clear? Okay. So with this let us proceed further. So next what I am going to do, the thing is, for an example I will take a function here, right? A given function is x of t. Let me consider e power minus jt. That is a function, right? Now the question is find whether the given signal is conjugate symmetric or anti-conjugate, that is conjugate anti-symmetric or conjugate symmetric or neither conjugate symmetric nor conjugate anti-symmetric. அந்த மாதிரி क्वेश्चन கேக்குறாங்க அப்படினா how will you proceed further? Let us proceed. X of t is given. Let us check. அப்ப நம்ம conjugate symmetric find பண்ணோம் அப்படினா first step find the value of x of minus t. X of minus t find பண்ணா என்ன வரும்? It is going to be e power minus j minus t, such that what I am getting here e power jt. I am getting e power jt. Now I am going to find the value of x conjugate of minus t. This is x of minus t. If I conjugate everything அப்படினா what do we mean by conjugation? Conjugation in the sense, for example, if I have a complex signal, simply understand, even while taking conjugate எடுக்கும்போது என்ன அப்படினா imaginary part of the signal ஓட sign வந்து change ஆகும். Just to remember, part of that is sign of the imaginary part of the signal will be changed. That is, if I have plus j, it will become minus j. If I have minus j, it will become plus j while taking conjugate. Just imaginary signal மட்டும் என்ன ஆகும், அது sign change பண்ணிக்கும். See there, since e power j ங்கிறது complex தான், right? That is imaginary. J is an imaginary operator. அப்ப conjugate எடுத்தீங்க அப்படினா sign of the imaginary operator will change. It will become e power minus jt. See there, x of t and x of, that is x conjugate of minus t are going to be equal to each other. So the conclusion is the given signal is what? It is an conjugate symmetric signal, right? So this given signal is conjugate symmetric signal. Clear? Now let me take one more example. Let me have this one, right? Let us take one more example here. Now what I am going to do, instead of taking that one, let me write x of t is equal to e power j mod t. Let us write mod t. Let us test, right? Take the same signal and we have to test whether the given signal is conjugate symmetric or not, right? So conjugate symmetric அப்படினா we are traveling along with the complex signals. It will be the real and the imaginary part of the that is there's both real and imaginary parts, right? Anyway, let us proceed with this. Now what I am going to do, just to find out the value of x of minus t first. X of minus t e power j mod of minus t, but what we know, it will be equal to e power j mod t only. We know the property of mod t now. So in the next step, just to take the conjugate, x conjugate of minus t should be equal to e power conjugate. While taking the conjugate, property of j will change, right? So it will become minus j times of mod t. Now see there, x of t and x conjugate of minus t are not going to be equal to each other. So the conclusion is that given function is not conjugate symmetric. That is not conjugate symmetric. Why? Because x of t and x conjugate of minus t are not equal. Let us check. At least in the condition satisfy தான் பார்க்கலாமா? இந்த கண்டிஷனுக்கு என்ன வேணும்? x of t equal to minus of x conjugate of minus t. I have x conjugate of minus t. If the minus ஆல மல்டிப்ளை பண்ணினா here also will become minus. See there, again they are not equal. So the conclusion is x of t and x of that is x of t and x conjugate of minus t are not equal. X of t and minus x conjugate of minus t are also not equal. So the conclusion is this given signal is neither conjugate nor conjugate anti-symmetric. ரெண்டு ப்ராப்பர்ட்டியுமே இதுல கிடையாது. The given signal will be the combination of both. It will be the combination of both. அப்ப என்ன பண்ணுவீங்க? If a given signal ரெண்டு பேரோட காம்பினேஷன்ல சேர்ந்து வந்தது அப்படினா let us see how to calculate the the part of ஒரு சிக்னல்ல ரெண்டுமே கலந்து இருக்கு சார். கான்ஜுகேட் சிமெட்ரிக்கும் இருக்கு, ஆன்டி கான்ஜுகேட் சிமெட்ரிக் கம்பைன் ஆயிட்டு வந்தது அப்படின்னா that signal is called neither conjugate nor anti conjugate nor conjugate symmetric, neither symmetric nor, that is neither conjugate symmetric nor conjugate anti symmetric. இப்போ அந்த மாதிரி சிக்னல் எப்படி இருக்கும்? லைக் நம்ம என்ன பார்த்தோம், ஈவன் அண்ட் ஆட் சிக்னலை பத்தி டிஸ்கஸ் பண்ணிட்டு இருக்கும்போது ஒரு சிக்னல் வந்து ஆட் சிக்னலாவோ இல்லை ஈவன் சிக்னலாவோ இல்லை அப்படின்னா that signal will be the combination of linear, that is odd and even signal. Like that, இது எடுத்து அதே ப்ராப்பர்ட்டிஸ் தான். So let us proceed. So like that, if இந்த மாதிரி சிக்னல்ஸ் வரும்போது how to grab the conjugate symmetric part and the anti conjugate symmetric part. For that we are using the standard formula. So the formula that we are going to use this one for this to find out the conjugate symmetric part of the signal, right? To find out the conjugate symmetric part of the signal, the formula is what? Same formula, that is x of t plus x of minus t, but we have to take conjugate. That is the one only difference, and we can divide it by 2. Similarly, anti-conjugate, that is conjugate anti-symmetric or anti-conjugate symmetric, right? So let me write conjugate anti-symmetric part of the signal can be written as x of t minus x conjugate of minus t whole divided by 2. That is the formula that we are using to find out the value of x, that is conjugate of anti-symmetric part of the signal. Shall we proceed? Yes. So now I know the value of x of t. We will also know the value of what I can say x conjugate. Let us see. Let me write them separately. X conjugate of minus t is this one, minus x conjugate of minus t should be equal to minus of e power minus t into mod t. Now I know these two values, this side also we know, and we are going to use them to find out the value of conjugate symmetric and conjugate anti-symmetric. Let us proceed. Let me rub these things here. Let me rub these things here. Let us proceed. Let us see how we are going to bring the answer for this one. So to bring out the, in order to bring the answer, conjugate symmetric part of the signal, how will you write? X of t, this is x of t, e power j mod t, e power j mod t, and then what I can suggest, plus x conjugate of minus t. X conjugate of minus t is plus e power minus j mod t. Yes. So, and we have to divide it by 2. We have to divide it by 2. This is conjugate symmetric part of the signal. Similarly, how will you find out the value of conjugate anti-symmetric part of the signal, right? To find out the conjugate anti-symmetric, this is conjugate symmetric actually. Conjugate anti-symmetric in the sense x of t e power j mod t, x of t minus x conjugate of minus t, that should be equal to minus e power minus j mod t divided by 2. Clear? Now with this, how will you reduce these two functions further? Actually, I hope you all remember the Euler expansion of e power j theta, right? E power j theta. The Euler expansion of e power j theta can be written as, okay, first let me write it here, e power j theta plus e power minus j theta upon 2 simply can be written as cos theta. Similarly, e power j theta minus e power minus j theta divided by twice of j equal to sin theta. Suppose if I have only 2 here, then this j will come here. In the other j, that j will be present here. In the j, you can consider only sin theta, right? So let me keep these two things and see that e power j theta, theta is mod t, e power j theta plus e power minus j theta divided by 2. So that can be written as cos of mod t. Now, this one can be written as e power j theta minus e power minus j theta divided by 2. That can be written as j times of sin of theta is being considered as mod t. Now, that is how we are finding conjugate symmetric and conjugate anti-symmetric of the any given signal. Now, the conclusion is, sir, is it true? Upon our given signal, the e power j theta. Actually, what I took the example is what we consider. What was considered? X of t can be plus e power j mod t. That is what I took. That is what I took, right? So let me combine them. If I already combine, so if I write the value of conjugate symmetric part of the signal plus conjugate anti-symmetric part of the signal, it is going to be cos of mod t plus j times of sin of mod t. That should be equal to what? E power j times of mod t. So what is the conclusion here? Yes or no? Cos theta plus j times of sin theta is nothing but what? E power j theta, right? So that is the Euler expansion. That is e power j theta can be written as what? Cos theta plus j times of sin theta. So the conclusion is, what is the conclusion here? Our given signal is the combination of conjugate symmetric and conjugate anti-symmetric. Clear? So that is how we are segregating. Anyway, Till now, whichever the things that we saw for even signal, odd signal, conjugate symmetric and anti-conjugate symmetric, எல்லா இடத்துலயும் நான் என்ன வச்சிருக்கேன் அப்படின்னா இங்க t, right? t அப்படிங்கிறது என்னது? t நான் யூஸ் பண்றேன் அப்படின்னா that is for continuous time domain. If I am using n, then I am meaning it, that is for discrete time domain, right? So if I talk about discrete time domain, once again just I will relate the functions in discrete time domain. See there, in continuous time domain we are writing it as x of t, right? Whereas the correspondent relation, when we are going from continuous time domain to discrete time domain, first step we have to sample the signal with a proper sampling interval such that it will become x of n, right? So sample பண்ணீங்க அப்படினா discrete time வந்துரும். n ஓட வேல்யூ வந்து என்ன வந்துரும்னா 1 2 3 4 5 6. We are discretizing with the help of proper interval. Clear? So that is the difference between time domain and discrete domain. So t will be simply replaced by n and open bracket will be replaced by open interval will be replaced by closed interval. That is the difference between continuous time domain and discrete time domain. So let us take இப்போ even function. First நம்ம என்ன பார்த்தோம்? In case of continuous time domain, for even function this condition is x of t is equal to x of minus t. If a signal satisfies this condition, then that is called even function. Same thing for the even function in case of discrete domain. That is for discrete, this is for continuous. In discrete domain, it can be written as x of mod n should be equal to x of, that is not mod n, x of n should be equal to x of minus n. Similarly, in case of continuous time domain, same procedure. You no need to, what I can say, similar examples that I am not going to do because same relations are going to be taken. In both domains, procedure will be same. I mean, என்ன பண்ணனும் அதே தான் அங்கேயும் பண்ண போறோம். But the only thing is here I am considering t, here I am considering n, right? So let us proceed with this. Odd function can be written as here x of t can be written as minus x of minus t. Whereas in discrete domain, same way it can be written as x of n equal to minus x of minus n. That is the difference between continuous time domain and discrete time domain, right? So wait a minute, yeah. Let me write the rest of things. Now the properties. In case of odd function, suppose in case of continuous time domain, if the given function is neither even nor odd function, in that case, how will you find out the even part of the signal? Even part of the signal in continuous domain can be predicted by x of t plus x of minus t divided by 2. Whereas in discrete domain, it can be written as even part of n should be equal to x of n plus x of minus n divided by 2. Similarly, odd part of the signal can be written as, let me write over here, odd part of the signal in, okay, let me rub these things. I hope you all have been completed this one, right? So let me rub this one. Let us continue. Similarly, how will you write the odd part? If you want to write the odd part of the signal, right? So let me write, in case of time domain, continuous time domain, odd part of the signal can be written as x of t minus x of minus t divided by 2. Similarly, in case of discrete domain, same thing, but it will be written in terms of n. So it can be written as x of n, right? Plus, sorry, it is not x of plus n, minus x of minus n whole divided by 2. Similarly, when we are discussing about conjugate symmetric, in case of continuous domain, conjugate symmetric, x of t is equal to x conjugate of minus t is going to be for conjugate symmetric. In discrete domain, x of n should be is equal to x conjugate of minus n. That is for conjugate symmetric. Whereas for anti-conjugate symmetric, it can be written as x of t should be is equal to minus x conjugate of minus t. Right? So here it can be written as x of n should be is equal to minus x conjugate of minus n. Right? Similarly, in time domain, how we are finding out the conjugate symmetric part? இப்போ signal, given signal வந்து neither conjugate symmetric nor conjugate anti-symmetric. அந்த மாதிரி function வந்தா, for an example, given it is neither conjugate symmetric nor anti-conjugate symmetric. இந்த மாதிரி function வந்தது அப்படின்னா, in that condition, how we are finding in time domain, conjugate symmetric part of the signal can be predicted with the help of x of t plus x conjugate of minus t divided by 2. Whereas in discrete domain, it can be written as conjugate symmetric. For n domain, it can be written as x of n plus x conjugate of minus n whole divided by 2. Similarly, for anti-conjugate symmetric, how will you find out the answer? Let us proceed. Yeah, let me rub this one. Wait a minute. Yes. Sorry guys. Okay, let us adjust. So anti-conjugate symmetric, right? That is x anti-conjugate symmetric part of the time domain, right? So the signal can be written as x of t, right, minus x conjugate of minus t divided by 2, that is in case of time domain. Whereas in discrete domain, anti-conjugate symmetric part of the signal can be written as x of n, right, minus x conjugate of minus n whole divided by 2. Clear? So that is the difference between what I can say time domain and discrete time domain. Guys, the analysis, right, it's not a big deal, right? We can easily analyze it, right? So there is no big difference between continuous time domain and discrete time domain, right? But the thing is, in time domain, that is continuous time domain, we are taking only n, right? Whereas in the discrete time domain, we are considering, sorry, in time continuous time domain, we are considering t. In the discrete time domain, we are considering sampled interval, that is n times of ts. Clear? The rest of procedure remains same, right? So let us see in the next lecture. We will start the next signal.